Alright, so this video we're going to go over the study guide number 1 through 3, and then 9 and 10. There would be separate video going over 4 through 8 since you use Desmo. So that's what you're looking for. Don't watch this. Identify the coordinate of each order pair in the semi-log to the left. So this is a semi-log plot. Quick review. Your x-axis are equally spaced like we've seen before. But look at your y-axis. So 10 to the 0 power is a 1. So this y value is a 1. 10 to the first power is 10. And then 100 and 1,000 and 10,000 and so on. So it's multiplied by 10. So they're not equally spaced like we've seen before. Instead, they're logarithmically scaled. Okay, so let's start with this point right here. I'm going to say that's point A. Okay, so what's the coordinate of point A? X comma y. X value is going to be 1, comma. Y value is over here. That's 10, 20, 30. So that one has a coordinate of 1, comma 30. What about point B? X value is going to be 4. Y value is going to be 100. So B is going to be 4, comma 100. C, excuse me. X value is 6. Y value is, let's see, 100, 200, 300, 400. So it'll be 6, comma 400. It's almost like it's counting. Last but not least, this point right here, point D, coordinate will be X value 8. Y value, this line, thick line right here is 1,000. So it's going to be 2,000. Plot each of these points on the semi-log plot. I'm going to change the color so it's less confusing. The first point is 2, comma 3. Sorry, quick. All right. X value is a 2, Y value is a 3. So 1, 2, 3 right here. 1, 2, 3. That's point A. Point B, 3, comma 50. 10, 20, 30, 40, 50. Right here, point B. Alright, just since we're there already, quick reminder, it's not going to be in the middle of 10 and 100, right? So this is a 10, this is a 100. Where would 50 be? In your mind, you should be thinking that's in the middle. No, but since it's not equally spaced, it's a big space and gets a little bit, 50 is going to be more than the halfway on the top of it. Okay? C, 9, comma 3,000. Oh, 1,000, 2,000, 3,000 right here. C. Okay. Number 3 is the data that is plotted in the semi-log plot best modeled by exponential or not. So I'm talking about this A and B and C and D. So quick reminder, on the semi-log plot, if it's a linear, that means it's an exponential. Exponential. So there's A and B and C and D. Does it look to be a straight line, linear to you? No, it's not linear. So I'm going to say, nope, it's not linear because it doesn't look straight line. Sorry, I don't want to write. I'm too lazy. Okay. The dots do not form a straight line. That's what the answer key says. All right, I'm going to go to number 9 now. Remember, this segment, I'm going to make another video. The data shows on the semi-log plot, if the exponential regression is used to model the data, which of the following claim and explanation statement best fit the data? Okay, so 2 statements I want to go over. So if it's the line, or it's a linear function, semi-log plot, that means the function itself is going to be exponential function. So if it does not look linear on the semi-log plot, it's probably not going to be exponential. Second, if it's a good model, no pattern on regression, on residual plot. Remember the residual plot, the actual minus predicted value. If it's a bad model, there's going to be a pattern on residual plot. So these 2 things that we have to remember. All right, so let's go. The data shows a semi-log plot. As you can see, it seems to be a straight line. So there's a straight line on the semi-log plot. So what does that mean? That means the function is exponential function. Oops, you can see. You good? Alright, so if the exponential functions were to be used and there is a residual value, it's a good model, right? Exponential. It says exponential regression is used. It's going to be a good model. So there's going to be no pattern on the residual. So I'm going to say the residual plot will have a no clear pattern because exponential function model was appropriate. Letter D says because exponential is not appropriate. It is appropriate. It's showing me it's exponential. So when you run the regression, it's a good model. No pattern. Alright, next one. I'm going to use the same one. If the exponential regression was used to model this data, do you see a straight line? No straight line. That means it's not exponential function. So if you were to run the exponential regression on this, is it a good model or a bad model? It's a bad model. If it's a bad model, is there pattern or no pattern? If it's a bad model, there is pattern on the residual plot. Okay, so residual plot will show a pattern because exponential function was appropriate or not appropriate? Not appropriate.